ನಿನ್ನೆ ಮಾತ್ರ ಬಹಳ ಇದ್ದಾವೆ.
ಏನು ಸೆಕೆಂಡ್ ಗಂಗಾಧರ್ ಸರ್
ಹಲೋ ಸರ್. ಹಲೋ ಗಂಗಾಧರ್ ಸರ್.
ಹಲೋ ಸರ್. ಹಲೋ ಸರ್.
ಸರ್ ನಮಸ್ತೆ.
ನಮಸ್ಕಾರ ಪ್ರೊಫೆಸರ್ ಮಧುಕುಮಾರ್, ಹೇಗಿದ್ದೀರಿ?
ಆರಾಮಿದ್ದೀವಿ ಸರ್.
ಸರ್ ನೀವು ಮತ್ತು ಕರಬಸಪ್ಪ ಎಚ್ ಬ್ಯಾಡಗಿ ಇಬ್ರು ಸರ್, ನಿಮ್ದು ಅಸೋಸಿಯೇಟ್ ಪ್ರೊಫೆಸರ್ ನೀವು? ಅಸಿಸ್ಟೆಂಟ್. ಮತ್ತೆ ಇವರು ಪ್ರೊಫೆಸರ್ ಕರಬಸಪ್ಪ ಬ್ಯಾಡಗಿ ಅವರು ಪ್ರೊಫೆಸರ್ ಅಲ್ಲ? ಹಲೋ, ಕೇಳ್ತಾ ಇಲ್ಲ ಯಾಕು? ಹೌದಾ? ಕರಬಸಪ್ಪ ಸರ್
ಸರಿ ಸರ್, ವಿಡಿಯೋ ತೋರಿಸ್ತೀವಿ, ಮುಖ ತೋರಿಸ್ತೀವಿ.
ಮಧುಕುಮಾರ್ ಮಾತಾಡ್ತಾ ಇಲ್ಲ.
ಕೇಳಿಸ್ತೈತಿ ಸರ್, ಇಲ್ಲಿಗೆ ಬರ್ರಿ, ನೀವು ಇದನ್ನ ಮಾಡ್ರಿ ಸರ್, ಮ್ಯೂಟ್ ಮಾಡ್ರಿ.
ಡಾಕ್ಟರ್ ಮಧುಕುಮಾರ್ ಕಾಣ್ತಾರೆ, ಕೇಳ್ತದೆ ಅವ್ರ ಮಾತು. ಸರ್ ನಿಮ್ ಮಾತು ಕೇಳ್ತಾ ಇಲ್ಲ ಸರ್. ಅಲ್ಲ, ಇನ್ನೊಬ್ರು ಮಾತಾಡಿದ್ರು ಅವರು. ಇಪ್ಪತ್ತೆಂಟು ಜನ ಇದ್ದಾರೆ.
ಸರ್ ನಮಸ್ಕಾರ ಸರ್. ಸರ್ ನಮಸ್ಕಾರ ಸರ್. ಸರ್ ನಾ ಕರಬಸಪ್ಪ ಬ್ಯಾಡಗಿ ಅಂತೇಳಿ ಸರ್. ಸರ್ ಮಧು ಅವರು ನಾವು ಕೂಡಿ ಮಾಡಿರೋದು ಸರ್. ಹಲೋ ಸರ್.
ಗಂಗಾಧರ್ ಸರ್ ಪ್ಲೀಸ್ ಅನ್ಮ್ಯೂಟ್ ಮಾಡಿ ಸರ್ ಮೈಕ್.
ಹಲೋ ಸರ್, ನಮಸ್ಕಾರ ಸರ್.
ಸರ್ ನಮಸ್ಕಾರ ಸರ್.
ಪ್ರೊಫೆಸರ್ ನಮಸ್ಕಾರ.
ಸರ್ ನಮಸ್ಕಾರ ಸರ್.
ನಮಸ್ಕಾರ, ಹೇಗಿದ್ದೀರಿ ಸರ್?
ಸರ್ ಆರಾಮಿದ್ದೀವಿ ಸರ್, ನೀವ್ ಆರಾಮಿರ್ಬೇಕು ಸರ್. ನೀವ್ ಆರಾಮಿದ್ದೀರಿ, ನಾವೆಲ್ಲ ಆರಾಮ್ ಸರ್.
ನಮಸ್ಕಾರ, ಆಗ್ಲಿ ಸರ್, ನಾನು ಆರಾಮಿದ್ದೀನಿ ಸರ್.
ಸರ್ ನೀವ್ ಆರಾಮಿರ್ಬೇಕು ಸರ್, ಪ್ಲೀಸ್ ಸರ್.
ಥ್ಯಾಂಕ್ಸ್ ಸರ್, ಥ್ಯಾಂಕ್ಸ್ ಸರ್. ನಿಮ್ಗೂ ಡಾಕ್ಟರ್ ಮಧುಕುಮಾರ್ಗೂ ಥ್ಯಾಂಕ್ಸ್
ಸರ್. ನಿಮ್ದು ನಮ್ಗೆ ಗೈಡೆನ್ಸ್ ಬೇಕು ಸರ್. ನೀವ್ ಆರಾಮಿದ್ದೀರಿ, ನಾವೆಲ್ಲ ಆರಾಮಿದ್ದಂಗೆ ಸರ್.
ಆಗ್ಲಿ ಸರ್, ಥ್ಯಾಂಕ್ಸ್ ಥ್ಯಾಂಕ್ಸ್ ಸರ್, ತುಂಬಾ ತುಂಬಾ ಥ್ಯಾಂಕ್ಸ್. ಸರ್ದು ಯಾವ್ದು ಸ್ಪೆಷಲೈಸೇಷನ್ ಸರ್ ಪ್ರೊಫೆಸರ್?
ಸರ್ ನಮ್ದು ಕೆಮಿಸ್ಟ್ರಿ ಸರ್.
ಕೆಮಿಸ್ಟ್ರಿ. ಆಗ್ಲಿ ಸರ್, ನೈಸ್ ಆಫ್ ಮೀಟಿಂಗ್ ಯು ಸರ್.
ಓಕೆ ಸರ್, ಥ್ಯಾಂಕ್ ಯು ಸರ್, ಸೇಮ್ ಟು ಯು ಸರ್.
ಥ್ಯಾಂಕ್ಸ್ ಥ್ಯಾಂಕ್ಸ್ ಸರ್, ಥ್ಯಾಂಕ್ಸ್ ಸರ್.
ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೀವಿ ಸರ್.
ನಿಮ್ಗೆ ಬುದ್ಧಿ ಕಲಿಸ್ತೀನಿ ಅಂತ ಅಂದ್ರೆ ಜೀವನ ಪರ್ಯಂತ ನೆನ್ಪಿಟ್ಕೋಬೇಕು. ಮೆಣಸಿನಕಾಯಿ ತಿಮ್ಮಣ್ಣನ ಹತ್ರ ಇಟ್ಕೊತಾನ ಅವನು. ನಾನು ಅವ್ನಿಗೆ ಹೇಗೆ ಬುದ್ಧಿ ಕಲಿಸ್ತೀನಿ ಅಂತಂದ್ರೆ ಮೆಣಸಿನಕಾಯಿ ಎಲ್ಲಿ ಅಂದ್ರೆ ಜೀವನ ಪರ್ಯಂತ ಅವ್ರು ತಿಂತಾಯ್ಬೇಕು. ಏನು ಕರ್ಚೀಫಲ್ಲಿ ನಿದ್ದೆ ಮಾಡೋ ಔಷಧಿ ಹಾಕಿ ಅವನಿಗೆ ಹೇಗೆ ಮಲಗಿಸ್ತೀನಿ ಅಂದ್ರೆ ಆಮೇಲೆ
ಯಾಕೆ ಅಲ್ವಾ ಇದ್ರಿಂದ ಕವರ್ ಆದ
ನೀವು ಅವನು ಮುಂದುವರ್ಬೇಕು, ನೀವು ಮುಂದುವರ್ಬಿಟ್ರೆ ಸಾರಿ ಈ ಪ್ಲಾನ್ ಏನಾದ್ರು ವರ್ಕೌಟ್ ಆಗಿಲ್ಲ ಅಂದ್ರೆ ನನ್ನ ಹತ್ರ ಇದಕ್ಕಿಂತ ಇನ್ನೂ ಒಂದು ಒಳ್ಳೆ ಪ್ಲಾನ್ ಇದೆ.
ಡಾಕ್ಟರ್ ಮಧುಕುಮಾರ್ ಸರ್, ಪ್ಲೀಸ್ ಕ್ಯಾರಿ ಆನ್ ಸರ್.
ಆಮೇಲೆ ಈ ಕಾರವನ್ನ ನಿಧಾನವಾಗಿ ಮಾಡ್ದಾಗ
Very good afternoon to today, and welcome to the webinar for all the third day of the FDP multidisciplinary programs. So I am privileged to introduce today our guest of honor and keynote speaker of the distinguished guest, Dr. H. Gangadhar Bhatt sir. The Gangadhar Bhatt sir is an education qualification, MSc, MPhil, PhD. He currently the professor of Mangalore University, Department of Marine Geology. So the professional teaching experience is more than 26 years. So research area is geology, geomorphology, remote sensing, and GIS, satellite, and oceanography.
Madhukumar sir, please unmute.
Yes sir, yes sir. And the research area for Dr. H. Gangadhar Bhatt is geology, geomorphology, remote sensing, and GIS, satellite, oceanography. His professional teaching experience is more than 26 years. The research guided more than 10 students are completed. Currently ongoing registered students, more 8+ students. The national international publications, research journal published in the international journals, more than 30+ journals, national 30+ journals. His book edited and translated, published more than 4 books. The poster presentation in national and international conference, the symposium is international, more than 4+, national 4+. The impact of publication H index is 8, I10 H index is 6, citation more than 136. So is organized one-day workshop on rainwater harvesting, groundwater recharging on 30th December 2019, and is awarded and fellowship recognized Indian National Science Academy Fellowship during the 2002 and 2003. Is a membership of professional bodies like a member of the Geological Society of India. Is a member of Indian Society of Remote Sensing. Is a member of Indian Society of Geomatics. So he involved in e-content development under the consortium of education UGC programs. He developed a YouTube video related to the remote sensing application and rainwater harvesting. And his research project is completed. Research project is entitled on estimation of modeling of suspended sediment, littoral transportation, and coastal dynamic along with coastal water of southern Karnataka coast. Indian organization with Indian Space Research Organization ISRO, and amount is 9 lakh. Duration is completed 2001 to 2006. And another one project is integrated coastal zone management plan for Karnataka. Ministry of Environment of Forest MOEF, 8 lakhs is completed 2003 to 2004. And another project is in implementation of geoacoustic approach for obtaining seabed properties in shallow water regions. Is the funding is a Naval Research Board, New Delhi, 21 lakhs, completed 2008 to 2011. So impact of sea level, another project is completed. Impact of sea level functioning along Karnataka coast based on remote sensing. The funding agency MOE New Delhi 27 lakhs 2009 to 13. Is a professionally presentation more than 18 conference national and international levels. Sir, over to you, sir. Welcome you, sir. Heartily welcome to our webinars. Please over to you, sir.
Good afternoon to everybody. Thank you, Dr. Madhu Kumara, for your kind words. So, respected Dr. Madhu Kumara, Professor Karabasappa H. Badagi, and dear participants. So, can you hear me, sir?
Yes, sir. Yes, sir.
Is it okay?
Okay, sir. Okay.
Hello.
Yes, sir, you're audible. Just continue.
Okay. So, good afternoon to everybody. Respected Madhu Kumar,
Yes, sir.
then Professor Karabasappa H. Badagi, and my dear participants. So, I will be speaking on fundamentals of remote sensing and its applications, maybe for another 60 or 75 minutes. So, I will start with fundamentals. So, basics of remote sensing. So, how best we can make use of this technology in natural resources mapping, on that I will be talking. So, before that, I wish to discuss some of the fundamental concepts of remote sensing, especially the satellite remote sensing, aerial remote sensing. Then by using ground platforms, we can remotely collect the data. Can I have the PPT slides, please, sir?
Yes, sir. Yes, sir. Cost ಆಯ್ತು ಇದೆ PPT ಬಂದಿತ್ತು. Sir, is it visible PPT?
No, sir. No, not yet. Now it is okay.
Okay.
Now it is visible. ಇಷ್ಟೇ ದೊಡ್ಡ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗುದಿಲ್ಲ. ಸರಿ. So I will be discussing. Shall I start, sir?
Yes, sir. Yes, sir. Please.
So fundamentals and applications of remote sensing. So let us discuss the basic concepts, the fundamental concepts of remote sensing. So you are seeing the imagery. Can anybody tell which area it covers? So normally in remote sensing, we say a picture is worth 1,000 words. So when you are observing this imagery, so you are seeing, see, can I have this slide full screen, sir, in a full screen? This slide? Yeah. See, can anybody tell which is this area?
CH college.
Yes, your own college. That is why I'm showing this imagery. So a picture is worth 1,000 words. That too, when we are considering an aerial photograph or satellite images, which are worth than thousands of words. So you can see in and around your college area, what kind of landforms are there, where you have the barren land, where you have the built up, where you have the vegetation. See, so much of information you will be able to gather by analyzing the satellite images. So here we are making use of remote sensing techniques. Next slide, please, sir. See, again, this is again showing the detailed information of your college campus and surrounding area. See where you have the vegetation, where you have the built up areas, playgrounds and all. See, maybe this is the 400-meter track. It looks like that. See, like that, see, without visiting the area, one can gather the required information. So these are all satellite images. So acquired by satellites. So remote sensing means sensing from a distance without any physical contact with the object. When I'm making use of these photographs or images, these are collected without any physical contact with the object. That means by making use of various sensors. Next slide, please. We are remotely collecting the data. You can show the slides are up, maybe some up to 7-8 slides you can show maybe in a minutes of time, because these are all images acquired by satellites without any physical contact with the object. Then this is the college, one more college, see, that is College of Education, maybe Haveri and Rani Bennur. So these two colleges are organizing this. That is why I have downloaded these images and now I am showing these images to you. These are all satellite images acquired from a distance without any physical contact with the object. Then you can see the next slide. See, this is our coastal area, the Karnataka coast covering part of the Suratkal area. You can see the coastal area, the beaches, the adjoining area and all. See, plenty of information you can gather. Of course, most of you are familiar about the Google Earth images. Google Earth images are nothing but that are acquired by satellite. See, even you can see the national highway connecting Mangalore and Mumbai. See, you can see even the vehicle on the road. See, double road, national highway. See, so much of information you will be able to gather by the analysis of satellite data. Next slide. See, this is of course the port area, Mangalore Port, New Mangalore Port Trust. Then we have the Bajpayee Airport and all. You can see this is of course a river, then built up area and beaches. Then near the shore you can see even the wave patterns and all. See, so much of information we will be able to gather through Indian remote sensing satellites or any kind of satellites, Landsat series of satellites and all. Of course, the next slide.
এটা লাল পিঁপড়ে নয়, ফুলে গেছে কেমন হয়ে গেছে এটা।
Hello?
এটা ওই জিনিসটাই হবে।
Hello?
সরাতে গেছি তো।
Hello, sir.
ওই যে ফুলে কেমন হয়ে গেছে।
No, sir, one of the, please mute your Suprati. Okay.
Hello, sir.
Please continue, sir.
Sir, can you see this cyclone? See, even the eye of the cyclone can be seen through this satellite imagery. Intensive cyclone, tropical cyclone activity has increased in the North Atlantic since about 1970, Hurricane Katrina 2005. See, you can even predict the monsoon well in advance. It is possible through Indian national satellites. We have different kinds of satellites like geostationary satellites. We have polar orbiting sun synchronous satellites and all. Polar orbiting sun synchronous satellites are used for natural resources mapping, whereas this kind of satellites, Indian national satellites, you are watching the DD news. At the end of the DD news, they used to show scattered clouds over coastal Karnataka, interior Karnataka and all. The prediction of monsoon is possible when it will be reaching Kerala coast or Karnataka coast. They are predicting well in advance by studying different parameters of the atmosphere like cloud top temperature, liquid water vapor content in the atmosphere, the type of clouds, then its movement, wind speed, wind direction. Number of parameters of the atmosphere can be studied, and based on that they can predict in which direction the cyclones are, these clouds are moving and all. They are predicting the monsoon also well in advance. All these are possible through remotely sensed data products. That means we have the satellites polar orbiting. They are having an altitude of 700 to 900 kilometers. And we have geostationary satellites like INSAT series of satellites. They are having an altitude of 36,000 kilometers. So coming to the remote sensing definition, see next slide, please. See, remote sensing means sensing from a distance. So it is the science and art of obtaining information, see, of the Earth surface features. See, if you want to get the required information of the Earth surface features, we are making use of the satellites. They are sensing from a distance and they are collecting the data without any physical contact. That means the electromagnetic spectrum plays a significant role. In fact, Dr. Madhu Kumar knows very well the basic principles of, see, all this comes under physics. See, electromagnetic spectrum, we are getting it from the sun. Sun is the chief source for the electromagnetic radiation. See, that energy is reaching the Earth's surface. It interacts with the Earth's surface features and retransmitted energy is recorded by a sensor of a satellite, which are having an altitude of 700 to 900 kilometers. See, we are sensing from a distance without any physical contact, and that means we are acquiring the data by a device that is not in contact with the object, area or phenomenon under investigation. That means regarding the Earth surface features, we are remotely collecting the data This is done by sensing and recording reflected or emitted energy of the Earth's surface. See, when the energy reaches the Earth's surface through sun, part of the light will be reflected, part is absorbed, and that absorbed energy is transmitted later on. That is called emitted energy. Then part of the light will be transmitted through the object. So normally in case of remote sensing, we are recording the reflected or emitted energy of the Earth's surface. See, one more definition of remote sensing. Next slide. See, it is nothing but the practice of deriving information. See, we have the satellite data. We have the aerial photographs. In the beginning, I said a picture is worth 1,000 words. See, we can make use of this satellite data for number of applications. From the data, we can extract the required information. See, that is what it is, the practice of deriving information about the Earth's land and water surfaces. Yes, we have 29% of the Earth's surface is covered with the land, 71% is covered with sea. So we have to gather the required information of the land and water surfaces, and that in the form of images which are acquired from an overhead perspective using electromagnetic radiation. That is the chief source. So that we are getting it from the sun in one or more regions of the electromagnetic spectrum. That means we have the gamma rays up to radio waves. We have the electromagnetic spectrum using different wavelength of the spectrum. You can see the electromagnetic spectrum. It normally ranges from gamma rays up to radio waves. See, gamma rays, X-rays, you have the ultraviolet, UV rays. Then you have the visible region of the spectrum. In the visible, we have the blue, green, and red portion of the spectrum. That is, blue is from 0.4 to 0.5 micrometer or 400 to 500 nanometer. Green is from 0.5 to 0.6 micrometer or 500 to 600 nanometer. 600 to 700 nanometer is the red region or 0.6 to 0.7 micrometer. See, micrometer and nanometer are the units normally used to measure the wavelength. Micrometer means 1 into 10 to the power minus 6 meter. Nanometer is 1 into 10 to the power minus 9 meter. So this is the electromagnetic spectrum normally used in remote sensing, but all these wavelengths are not at all useful in terrestrial remote sensing. So next slide, please. See, when we talk about remote sensing, there are two basic concepts. One is data acquisition, the other one is data analysis. First of all, we must acquire the data. See, through satellites, we need the satellite data. Hello? We need the satellite data or aerial photographic data. So when we analyze this, see, when the aircraft is taking the photograph, there is no physical contact with the object. When the spacecraft takes the image, there is no physical contact. In fact, whenever you are making use of your mobile, you are employing remote sensing, because without any physical contact, you are taking the photograph of a particular area or a particular person. There is no physical contact with the object. This is what it is called as remote sensing. So here, let us discuss the two basic concepts of remote sensing. First of all, we must acquire the data through aircrafts or spacecrafts. So our eye is sensitive to the visible region of the spectrum. Our eye is acting as a sensor mounted on human body, which is capable of recording the signals in the visible region of the electromagnetic spectrum. That means 0.4 to 0.7 micrometer or 400 to 700 nanometer wavelength. We can sense the Earth surface features. Like our eyes, there are eyes present in the satellites or aircraft called sensors, which are capable of sensing the Earth surface features, not only in the visible region, beyond the visible region also they can sense. That means they can sense in the invisible region of the spectrum also. That means infrared, thermal portion of the spectrum, microwave portion of the spectrum, there also they can sense the Earth surface features. So let us discuss the data acquisition part first. So you have the sources of energy, the electromagnetic radiation, so or electromagnetic energy, which comes from the sun. So sun is the chief source for the electromagnetic radiation. Besides sun, every Earth surface feature whose temperature is above absolute zero, that is minus 273 degrees Celsius, they emit their own sources of electromagnetic radiation, but which is of different magnitude and composition than that of the sun. Now we have the solar energy. That energy has to propagate through the atmosphere. Before it reaches the Earth's surface, it has to propagate through the atmosphere, and there is a mechanism called scattering and absorption will take place. Combinedly, this process is called atmospheric attenuation. When the energy propagates through the atmosphere, see, there is a mechanism called scattering. That is nothing but dispersion or diffusion of radiation by the atmospheric particles. See, depending upon the interacting electromagnetic radiation and the atmospheric particle size, we have Rayleigh scattering, we have Mie scattering, and we have non-selective scattering. So in the case of Rayleigh scattering, the interacting electromagnetic radiation will have a larger dimension than the atmospheric particles. In the case of blue sky is the result of Rayleigh scattering. In the case of Mie scattering, the interacting electromagnetic radiation and the atmospheric particles are having equal dimension. In the case of non-selective scattering, which is the reversal of Rayleigh scattering, in the sense atmospheric droplets will have a larger dimension than the interacting electromagnetic radiation. Because of this scattering, the contrast of the image gets reduced. When you are analyzing the satellite imagery, the raw data are not providing that much of information because the scattering effect will be there. Then finally, there will be absorption. See, atmosphere is made up of gaseous molecules, dust particles and all. Atmosphere does not allow all the electromagnetic radiation to pass through it. Only certain wavelength of the electromagnetic radiation can pass through the atmosphere. So the atmosphere, which is acting as a transparent media, that is called as atmospheric windows. So we have the atmospheric windows in the visible region, in the infrared region, in the thermal region of the electromagnetic spectrum. So atmosphere allows some of the wavelength to reach the Earth's surface. That means visible region, infrared region, thermal region, microwave portion of the spectrum can reach the Earth's surface, whereas gamma rays, X-rays, UV rays are completely blocked by the atmosphere. Then the energy will be interacting with the Earth's surface features, and they will be interacting means there is a reflection, absorption, and transmittance. See, when the energy reaches the Earth's surface, it interacts with the Earth's surface features. Then part of the light will be reflected, part is absorbed, and part is transmitted through the object. And these three will be different for different Earth surface features. If you take, for example, the sandy beach or the desert area where you have the sandy material, which reflects maximum light, you have the water bodies which absorbs all the electromagnetic radiation. It looks black. See, like that, different surface features will behave differently when an electromagnetic radiation is incident upon that. That means part of the light will be reflected, part is absorbed, and part is transmitted through the object. This reflected or emitted energy will be recorded by a sensor of a satellite. So we have the low altitude aircraft, medium altitude aircraft, then we have the high altitude spacecraft. These are sensing the electromagnetic radiation. They are recording the reflected or emitted energy of the Earth's surface. So they are comprising of sensors. So up to this stage, it is called as data acquisition. We are acquiring the data using ground platform, aerial platform, space platform. Then that data must be analyzed. That is called data analysis. Maybe we have to interpret the satellite images. See, the present satellite images are capable of detecting even a vehicle moving on the road. When the first satellite was launched in the year 1972 by NASA of USA, that satellite was capable of detecting 80-meter object of the Earth's surface. The technology advanced. We went from 80 meter to 72.5 meter, 36.25 meter, 30 meter, 20, 10, 5.8, 4 meter, 1 meter. Now some of the current remote sensing satellites, especially the Indian remote sensing satellites also, they are capable of detecting even 30 centimeter object of the Earth's surface. We must feel proud for our Indian Space Search Organization. Of course, India launched a series of satellites under Indian remote sensing satellites, under Indian national satellites and all. And even we launched Indian regional navigational satellites for global positioning purposes. So we have number of satellites. See, when India launched the first satellite in the year 1988 on March 18th, we launched the first Indian remote sensing satellite called IRS-1A. People were asking why a country like India has made and sent up a satellite instead of growing more food or digging more wells. Perhaps you may be little surprised to know that this satellite technology and food are very much interrelated. For growing more food, you need more accurate data on soil and water resources. As you go higher and higher, you will be able to see a larger area, and that is what it is called as a synoptic view or a bird's eye view. Of course, you will be able to see larger area if you climb a hillock or from the building top, you will be able to see a larger area. That is what it is called as a synoptic view. The aircraft or the spacecraft provide such kind of synoptic views, and that are available in the form of a photograph or image. Then when we analyze, when we interpret this data, we are getting some useful information about the Earth surface features. Now, the current satellites are capable of detecting even a vehicle parked in front of your house, whether it is a scooter or car. You can easily say that kind of high resolution images are available. See, this is a truck mounted platform. This is called ground platform, but sensor is there, which is collecting the data, maybe a camera or any kind of sensor, which record the signals of the Earth surface feature. So this is ground platform. Next slide. Next slide, please. Then we have the aerial platform. See, go back to the previous. See, you have the aerial platform. That means aircrafts are being used to collect the required information. So we have ground platform, we have the aerial platform, we have the space platform. This is from the ground. This is from an altitude of 10 to 15 or 30 kilometers in the form of aerial photography. These are all satellite images. See, satellites are providing the satellite images. Next slide. See, in the case of aerial photography, see, one advantage of aerial photography is when the aircraft is here, it takes the photograph of this much area. Then when it goes to another position, the same area will be covered, but from a different angle. In this process, this much area is common in both the photographs. The resulting photographs are called stereo pairs. And when I observe such overlapped aerial photographs, I'm getting the stereoscopic vision, 3D view of the terrain, so that I can measure the height of a particular building. Without visiting your KLES GH College, Haveri, I can measure the height of the building with the help of 3D aerial photographs. So aerial photographs are providing the 3D images of the Earth surface. Next slide. See, here again, you can see how the aircraft is flying and it takes the photograph. See, same piece of land is covered from two different angles. It flies like this and takes the photographs. There will be a common overlap. Because of that, you are getting some 3D view of the terrain. Next slide. See, energy interacts. I said in the beginning, see, when the solar energy falls on the Earth's surface, part is reflected, part is absorbed, and part is transmitted through the object. This can be expressed by a mathematical equation, that is incident energy means reflected energy plus absorbed energy plus transmitted energy. These three will be different for different Earth surface features. For example, sandy beach or desert, which reflects maximum light. Water bodies absorbs all the electromagnetic radiation. And there are different surface features which behave differently when an electromagnetic radiation is incident upon that. See, based on that difference, we will be able to identify the surface features on a remotely sensed data. See, now why we have to go for remote sensing? For example, if somebody wants to study the forest cover of the Western Ghats of Karnataka or Maharashtra or Kerala, see, or Himalayan terrain, the areas are inaccessible. You have the steep slope, thickly covered with the vegetation. See, you cannot visit each and every part of the area. That is through conventional technique. It is a tedious job, time consuming. But if you are really good in the subject of remote sensing, without visiting the area, whatever the data you are getting through satellites, that you can analyze and you can generate some useful maps. You can derive the required information from the data. That could be the aerial photographic data or the satellite data. You will be able to derive the required information. See how much of energy the surface features reflect. It depends upon the material type and condition. Based on that, you will be able to identify the surface features on a remotely sensed data. Next slide. See, we are getting different colors when we analyze the satellite images, or if you can see the vegetation, which looks green for us, because vegetation reflects in the green region of the electromagnetic spectrum because there is a chlorophyll. Because of that, it reflects in the green. Blue and red get absorbed. If you consider the visible light, which is blue, green, and red, combination of blue, green, and red, blue is having the shortest wavelength, 0.54 to 0.5 micrometer. Green is from 0.5 to 0.6. Red is from 0.6 to 0.7. Beyond that, you have the infrared. So here, green means it reflects in the green. The other two wavelengths will be absorbed, blue and red. In a similar way, yellow means, so it reflects in the, see, part of green and part of red, combination of green plus red results yellow. So like that, yellow, red color means it reflects in the red, blue and green, red get absorbed. Like that, we are getting different colors, and based on that, we will be able to differentiate the Earth surface features. Next slide. So we are measuring the spectral reflectance, how much of energy is reflected from the Earth's surface. See, that you can divide it by the amount of energy incident upon the object. So I said in the beginning, when the energy falls on the Earth's surface, part is reflected, part is absorbed, and part is transmitted. And these three will be different for different surface features. See, that means how much of energy reflects back. That if you divide it by the amount of incident energy, then multiply it by 100, you are getting the spectral reflectance in percentages. So this is the equation. Energy of wavelength lambda reflected from the object, say, let us say it is 60, divide it by the incident energy, that is 100, multiply it by 100, you are getting the spectral reflectance in percentages. It may be 60% here. So if you plot the spectral reflectance versus wavelength, next slide, you are getting the spectral reflectance curves. See, based on that, you can select which are the best bands for a particular application. So again, here you may have to differentiate two types of vegetation. Let us say one is deciduous forest, the other one is coniferous forest. See, when you click the camera, suppose you may be having the digital camera, you are clicking through your mobile, you are employing only the visible region of the electromagnetic spectrum. You are getting only one output, whereas that is why it is called as photography. Only visible region of the spectrum is used. But it is not in the case of a satellite. Satellites are having the scanners, which scans line by line. And the scanner views only a small area at a particular instant of time, and it is called as its instantaneous field of view, and which corresponds to the spatial resolution of that sensor. Now, we have two types of vegetation. I have to make use of the satellite data, and I have to differentiate the coniferous and deciduous forest. See, you may be having the forest area. You have to demarcate now where you have the deciduous forest. They are shedding their leaves at a particular season, broad-leaved species. You have the narrow-leaved species like coniferous forest. In a forest area, maybe in Dharwad district or Haveri district, you have to differentiate what kind of vegetation is there. See, you make use of this multispectral. In case of satellites, it is simultaneously recording the signals in more than one wavelength of the electromagnetic spectrum. That is why we say multispectral. Satellites are providing multispectral information. It records the signal simultaneously in the blue region, in the green region, in the red region, in the near infrared region of the electromagnetic spectrum. That means we are getting multispectral information. See, for example, in this case, this is an example of Landsat MSS data. Landsat satellite was launched by USA in the year 1972. That was the first satellite used for remote sensing purposes. See, it was having 4 spectral bands. Now that MSS is not there, a multispectral scanner was a sensor. I said in the beginning, sensors are nothing but the devices used to collect the information about the Earth's surface features. So we have different kinds of sensors. We have multispectral sensors, we have thematic mapper, active sensors, passive sensors, and imaging sensors, non-imaging sensors and all. In the case of active remote sensing, we make use of the artificial source of electromagnetic radiation as a source. For example, during night time, if the light is not sufficient, you are making use of the artificial source of energy as a source for photographic purposes. That is called active remote sensing. During daytime, you are taking the photograph. During daytime, solar energy you are making use of. That is called passive remote sensing. We have imaging sensors, we have non-imaging sensors and all. See, here we are making use of this multispectral concept. See, when 2 surface features, if you want to demarcate, you are making use of this blue region of the spectrum. In that wavelength, both of these surface features are having similar reflectance. You will not succeed in differentiating. You will make use of the green region. There also the difference is not that much. Both of them are reflecting, but in the red region, both of them are absorbing, but the difference is not that much. But you see in the near infrared region, coniferous trees are showing a reflectance of 30, deciduous trees are showing a reflectance more than 40%. That means I can easily differentiate these 2 types of vegetation in the near infrared region of the electromagnetic spectrum. I cannot sense, human beings cannot sense in the invisible region. They can sense only in the visible region from 0.4 to 0.7 micrometer, whereas the satellites can sense beyond the visible region of the spectrum, and they are simultaneously recording the signals in more than 1 wavelength of the electromagnetic spectrum. That concept is called multispectral concept. Next slide. See, now through remote sensing, by making use of the satellite data, when I say remotely sensed data products, which are acquired through ground platform, aerial platform in the form of aerial photography, in the form of satellite remote sensing, the end product is satellite images. See, now whenever you are making use of these satellite images, see, you can easily demarcate where you have the healthy vegetation, where you have the stressed vegetation. See, for that purpose, we are making use of this formula that is called normalized differential vegetation index, NDVI. You are measuring the reflectance in the near infrared as well as in the visible red. Visible red is absorbing the electromagnetic radiation. See, plants absorb the red portion of the spectrum, whereas they reflect highest amount of energy in the infrared. So if you take the ratio NIR minus visible red divided by NIR plus visible red, you are getting the values. See here, for the healthy vegetation, see, you are getting the higher NDVI value. See, you are getting 0.72. That means higher the NDVI value, it indicates it is a healthy vegetation that I can get through the analysis of remotely sensed data. This is a stressed vegetation. When the plant is subjected to some sort of stress, the chlorophyll production reduces. The result is it turns to yellowish. See here the DN value. See here, if you see the NDVI value, it is 0.14. That means it is a stressed vegetation. So like that, I can differentiate where I have the healthiest vegetation, where I have the diseased vegetation. In fact, in the agricultural field, we will be able to demarcate what type of crops are there, how much of area in Haveri district or Gadag or in Dharwad is covered with the paddy, sugarcane, jowar, maize. See, that kind of analysis, what is the aerial extent of the agricultural fields? And once I know the healthiness of the vegetation, Even I can calculate the yield. I can estimate the yield, how many tons of yield will be there. That is possible through the observation, through the analysis of remotely sensed data. Next slide. See, here you can see comparison of visible and infrared imaging. See, of course, this is a color composite. This is the true color where the vegetation is represented by green color. But here it is a false color because I said in the beginning, vegetation reflects maximum light in the infrared region of the spectrum of the visible, which reflects in the green. For us, vegetation looks green, but the satellite sensors are capable of detecting the signals not only in the visible region, they can sense beyond the visible region also. Since they are sensing in the infrared region, infrared bands are the best bands to delineate the vegetation. Now, of the two images, same area, but you see wherever red color are there, they're all vegetated areas. And difference in red will tell you the status of vegetation, whether it is an agricultural area or the forest area. Once the person's interpretation skill improves, he will be able to demarcate, see where the road network, where the railway network, where the vegetated areas, where the barren land, where the water bodies. See, I can demarcate. See, why we have to demarcate the water bodies? See, some of the areas are inaccessible. I cannot do the field work at regular intervals. But if I have the satellite imagery, I can tell what is the aerial extent of Krishnaraj Sagar Reservoir, Linganamakki Reservoir, or Tunga or Bhadra or Tungabhadra Reservoir, Harangi Reservoir, Alamatti Reservoir. How much water is available in a particular reservoir? The aerial extent of the water body can be monitored with the help of a satellite data. And again, the satellite images are available at regular intervals. Suppose a particular satellite passes over Haveri area or Ranibennur area today, the same satellite will pass over those two areas after 16 days, 32nd day, 48th day, 64th day, 80th day, like that. So if you divide 365 by 16, about 20 times, 20 to 24 times, the same satellite will pass over that area. That means you can monitor the significant changes related to water bodies. What was the aerial extent of the water body about 2 years back, about a year back, during summer months? How much water is available in a particular reservoir? Depending upon the availability of water, they are releasing the water. The end farmer, the farmer who is living about 30 kilometers from the canal, see, he may not get sufficient water. He cannot think of going for paddy. He has to think of some other crops. So in that context, there is a need to monitor the water resources, forest resources of an area. Remotely sensed data can be used for a number of applications. A geologist can make use of this for geological applications, water resources management, mineral exploration. A botanist can make use of this for forest resources mapping. Soil scientist can make use of this for soil resources survey. So town planner will have different approach. So for number of applications, we can make use of this satellite images. Next slide, please. So this is a satellite imagery. See, again, having regular rows and column arrangements. If you go on zooming the image, you will go to the pixel level. These small minute features on the image is called pixels, picture element. See, that are represented by some numbers that are nothing but the reflectance values of the Earth's surface. In fact, in the case of satellites, there are some devices which converts the analog values, the reflected or emitted energy, into digital numbers. So we are playing with these digital numbers. There is a technique. So through this technique, digital image processing, we can manipulate the image. We can extract maximum information from the images. The purpose is to get more and more information about the Earth's surface features. I said just now, remote sensing has wider applications. And in fact, it is one of the best technology or tool for resources mapping. See, for example, 71% of the Earth's surface is covered with the ocean. if you want to collect the required information of the ocean, see, even if you make use of ships or boats, thousands of ships or boats, you may not be able to cover each and every part of the ocean. Whereas satellites, if you have some 4 to 5 images, the entire world will be covered. Some of the satellites are capable of covering the entire world with some 5 to 6 scenes. Once you do the interpretation of these satellite data, you are getting some useful information about the Earth surface features. And normally, these are recorded in the form of a digital data. The digital numbers, they are nothing but, these numbers are nothing but representing the radiometric resolution. And these numbers are the reflected or emitted energy from the Earth surface. Next slide. Suppose the time is taken. 3, 4, 5. See, now you can see these are the Earth observation satellites. See, there are thousands of satellites orbiting over the globe, high in the sky. Now there is a traffic jam in the space. That means there is an international commission is there. An international commission has been set up and they are allotting the slots where to launch the satellite. See, thousands of satellites, different countries, America is launching, private companies of America is launching satellites. Developed countries are launching the satellites. European Space Agency, National Aeronautics and Space Administration of USA, National Oceanographic and Atmospheric Administration of USA, then Indian Space Research Organization, European Space Agency. There are a number of Japanese Space Agency, Chinese Space Agency. They are launching number of satellites. So orbits are crowded and there is a traffic jam in the space. That is why an international commission has been set up and they are allotting the slots where to launch the satellites. So these are Earth observation satellites. We have sun synchronous satellites, polar orbiting satellites. Their orbit is near polar. They are orbiting from north to south like this. Then we have geostationary satellites. Their orbit is they are having an altitude of about 36,000 kilometers. Their orbit is at an altitude of 36,000 kilometers. Their INSAT series of satellites, meteorological satellites, are having an altitude of 36,000 kilometers, whereas Indian remote sensing satellites and Landsat series of satellites are having an altitude of 700 to 900 kilometers, and they are polar orbiting satellites. And for the natural resources mapping purposes, we are making use of this Indian remote sensing satellites or Landsat series of satellites, which are polar orbiting sun synchronous satellites having an altitude of 700 to 900 kilometers. Next slide. See, this was the first satellite launched by NASA of USA in the year 1972. And that satellite, Landsat, carried a sensor called multispectral scanner, which collected the data in the 4 spectral regions of the electromagnetic spectrum. In the green region, red region, and near infrared region of the electromagnetic spectrum, there was no blue band at that time. It collected the data in 4 different spectral bands. So that was the specification of Landsat MSS. Landsat was the first satellite with the MSS, and one more sensor was their RBV, return beam VDCon. This is multispectral scanner. Then see, you can see the next slide. This is the Landsat satellite. So, and in the latest satellite, they removed that RBV and introduced one more sensor called thematic mapper, which started providing the required information with the 30-meter spatial resolution. I will be discussing those things, different kinds of resolution in the subsequent slides. Next slide. See, these are the Indian imaging systems, Indian remote sensing satellites. See, we launched the first satellite in the year 1988. The subsequent satellite in that series was IRS-1B. IRS-1A was launched during 1988. On March 18th, we launched the first Indian remote sensing satellite called IRS-1A. The subsequent satellite was launched in the year 1991. Then we launched IRS-1C and 1D during 1995 and 1999. And these satellites carried different kinds of sensors for imaging purposes. They provided useful information about the Earth surface features. Then we launched few more satellites by developing our own launching vehicle. We have developed the launching vehicle technology from ASLV, Augmented Satellite Launching Vehicle, to PSLV, Polar Satellite Launching Vehicle, to GSLV, Geostationary Satellite Launching Vehicle. Now we can send a satellite to the height of 36,000 kilometers. Again, I am repeating, we must feel proud for our ISRO, Indian Space Research Organization's activities. We have sent satellite to Mars in the first attempt. None of the other countries have succeeded in sending a satellite to Mars in the first attempt. We have sent satellite to Moon. Twice we have sent satellite called Chandrayaan program. If you want to know more about Moon, the Moon images are available. Mars images are available. If any researcher or any student, he wants to make use of the satellite data for different applications, yes, they can approach ISRO and they can get the required satellite data and they can do different kinds of resources mapping. In fact, you have a university located at Gadag, Karnataka State Rural Development and Panchayat Raj University. There they are offering MSc program in geoinformatics. In fact, geoinformatics mainly comprises of remote sensing, GIS, web designing, computer applications and all. We too in our university at Mangalore University, we are also offering marine geology and geoinformatics programs. We have 2 years programs in marine geology and geoinformatics. And geoinformatics mainly comprises of the satellite technology. And we have launched a number of satellites with the different sensors. They are having capability to collect the required information of the Earth surface features. Next slide, you can see how the satellites collect the signals and all. Hello, can you move the slide? Hello. See, this is how, this is a French satellite, how it collects. See, it gathers the required information. When the satellite orbits from north to south, see, it gathers the required information. Next slide. See, this is how 4 decades of Indian, now it is 5 decades almost. So we have launched more than 100 satellites. We have developed the satellite technology starting from IRS-1A with 72.5 meter spatial resolution LIS-1 sensor. Now we have launched recently, we have launched a satellite called Cartosat, which is capable of providing even 30 centimeter object of the Earth's surface. That means whether in front of your house you have a bike or scooter, that can be detected with the help of a Cartosat type of satellites. So we have different kinds of satellites with the different kinds of sensors. So one can do the interpretation and one can extract the required information. Next slide. See, this is the milestone, how we reached it. We have launched more than 100 satellites. Of course, this is the old PPT. Anyhow, see, next slide. See, in a similar way, we have developed the launching vehicles, see, starting from ASLV, Augmented Satellite Launching Vehicle, to a height of 300 to 400. Then we have developed this PSLV, Polar Satellite Launching Vehicle. Then we have developed the GSLV, Geostationary Satellite Launching Vehicle. Using that, we can launch 36,000 kilometer altitude satellite, especially the INSAT series of satellites. Then we have Indian regional remote sensing satellites and all. Next slide. See, Indian imaging capability. In the initial stages, it was capable of, see, 1 kilometer. Now, see, earlier it was a kilometer resolution. See, the technology advanced from 360 meter, 88 meter, then 72, 56 meter, 36, 23, 5.8, 2.5. Now you have even 30 centimeter object of the Earth's surface can be detected, 1 kilometer to 2.5 meter spatial resolution. Spatial resolution is nothing but the minimum area of the ground or smallest unit of the ground which can be resolved by a sensor, that is expressed in spatial resolution. Then 24 days to every 30 minutes. Every 30 minutes you are getting the required information so that you can monitor the dynamic changes. When it will be raining, in which direction the clouds are moving, where the cyclone is moving, and at what speed the winds are blowing. See, all this required information you can gather through satellite technology. Okay, next slide. See, this is how the satellites collect the signals. See, the satellite orbit is normally from north to south, and this is the equator. See, it requires nearly about 98 minutes to complete one full cycle of the Earth. Now, what happens by the time the satellite completes? See, the solid line is satellite orbit. That dashed line is on the Earth's surface, how much area it covers. It depends upon the swath width of the sensor. It varies from satellite to satellite. See, this is the solid line, that is the satellite orbit, and which requires about 98 to 99 minutes to complete one full cycle of the Earth. Now, what happens by the time the satellite completes one full cycle of the Earth in a span of 99 minutes? The Earth has rotated from west to east. That is why we are feeling the sun is moving from east to west. See, by the time the satellite completes one full cycle of the Earth is also rotated from west to east. Because of that, see, next slide, there will be a large gap between successive orbits on a given day. However, with each new day, the satellite orbit progresses westwards, and which will overlap the orbit patterns of the previous day. That means if this is the first orbit over Rani Bennur or Haveri area, the next orbit after 100 minutes will not be adjoining to Rani Bennur or Haveri. It will be at a gap of 2,800 kilometers west. Like that, it will be orbiting. Again, 14 orbits will be there on that particular day. However, with each new day, the satellite orbit progresses westward, and which will orbit the next area. That means there will be a small overlap. But see, if this is the first orbit over Rani Bennuru today, next day's first orbit will be adjoining to Rani Bennuru. Next orbit will be adjoining to the second orbit of the previous day, third orbit of the previous day. Like that, second day you have again 14 orbits, third day 14 orbits. In a span of 16 days, the entire world will be covered, and on the 17th day, the same satellite will be over Rani Bennuru area. That means you can monitor what type of crops were grown during summer season, during winter season, during rainy season. That you can monitor without visiting the area. By analyzing the satellite images, you will be able to say how much area is under paddy, how much area is under sugarcane. So that are possible through remotely sensed data. Next slide. See, when I talk about the satellite data, we have spatial, spectral, temporal, and radiometric resolution. These are four kinds of resolution. Spatial refers to the area, how much area it covers during its passage. That is the minimum area of the ground which can be resolved by a sensor. Spectral refers to at what wavelength of the spectrum the data is being recorded. Temporal means the repeativity. I said just now, if a particular satellite passes over Rani Bennur or Haveri or any part of Karnataka, after 16 or 17 days, again it will come over that area. So you are getting multi-dated satellite data, multispectral plus multi-dated. Then you have the radiometric resolution, that is the sensitivity of the sensor. Next slide. See, these are different kinds of resolution, again in detail. Visible as well as infrared and thermal portion of the electromagnetic spectrum. Then this is the radiometric resolution. It varies from sensor to sensor, satellite to satellite. Normally, satellites records 8 bits of data. It ranges from 0 to 255. See, this is of course the temporal resolution. So earlier they were carrying out the survey once in a year, once in 2 months, like that. Now, same piece of land can be imaged a number of times. So that is the advantage. So again, you can see here, 2004 Olympics were held at 2 venues. One is Spot 5 satellite data, French satellite. The other one is Iconos. You are watching the Google Earth and all. See, one of the venue, see, you are not able to see this venue properly here. This is coarse resolution. 117 kilometers swath width with the 20 meter spatial resolution. But here you see Iconos satellite data with the 13 kilometer spatial resolution and 4 meter, see 13 kilometers swath width and 4 meter. You can see the playground. What is the shape of this playground? Whether it is a diagonal, see, built up areas, so much of futures, playgrounds, different kinds of playgrounds, then built up areas, so much of information you will be able to gather with the higher spatial resolution. Of course, this is the advantage of high spatial resolution satellite images. Then see, you can see, next slide. See again the color composites with the resolution comparison, coarser, medium, and fine resolution. Fine means, see, even you can see the road network, built up areas, water bodies very clearly. Of course, these images are showing red color. Wherever red is there, they're all vegetated areas. Next slide. See, this is the multispectral data. See, these are the color composites. See, satellites simultaneously recording the signals at a different wavelength of the spectrum. See, the first band, blue region, green, red, and near infrared. When you combine these three bands, you are getting the true color, wherein the vegetation is represented by green color. But if you combine these three, green, red, and near infrared, you are getting this color that is called as false color composite. So there the vegetation is represented by red color. Definitely this is the best color composite to study the vegetation. Here that is not that clear, but here you can study the vegetation very clearly, and difference in red will tell you the status of vegetation. Next slide. See, now why we have to go for remote sensing? What are the advantages? Of course, this is the Manasa Sarovara area. See, you cannot visit each and every part of the area, the world, Himalayas, thickly covered with glaciers, the forested areas, Western Ghats covered with forests. So then steep slopes are there, inaccessible areas are there. Suppose you want to study the vegetation, forest cover of the Western Ghats, or rock types of the Western Ghats, geology of the Western Ghats, biodiversity of the Western Ghats. See, you cannot cover each and every part of the area, but if you are really good in the field of remote sensing, you can analyze the satellite data and you can generate some useful maps. For example, the synoptic coverage. The satellites are providing you the synoptic coverage. That means large area will be covered. Then repeativity, the same area can be seen. Of course, this is Manasa Sarovara area. You can see the water bodies. See, these are the water bodies, these are the glaciers, these are the forest cover. Different types of surface features are represented here. So if the person is good in the field of remote sensing, he can generate very useful maps based on the analysis of this satellite data. So which provides synoptic coverage, repetitive coverage, same area can be imaged a number of times. Then inaccessible area coverage, so number of inaccessible areas, especially the steep slopes of the Western Ghats or Himalayas, or any area which can be covered with the help of satellite data. So then information in spatial domain, in the sense I can calculate the aerial extent of this water body. What is the aerial extent of a particular water body? That is possible with the help of a satellite data. Then data is quantifiable. Yes, I can say the aerial extent of the water body, 10 square kilometer, 5 square kilometer. So it is quantifiable. Then large archives of historical data. That means since 72, we are getting the satellite data. Landsat was launched during 72. Then Indian remote sensing satellites were launched from 88 onwards. So if you want to have the earlier satellite data, that you can get it from NRSC. So anyhow, we have the satellite archives data for change detection studies and all. Large archives of historical data. These are some of the advantages of remote sensing. That is why conventional techniques, if you go for field work, it is time consuming, laborious job. But if you are really good in the field of remote sensing, by interpreting the remotely sensed data, which are available in the form of an aerial photograph or satellite images, you can generate a very useful thematic map, geology, geomorphology, land use, land cover, soil map, slope map, aspect map. So number of thematic maps can be generated. Next slide. See, this is the digital number remote sensing process, the satellites recording the signals that are available in the digital mode. You are processing, and there are different applications. For example, atmospheric related studies, because entire column of the atmosphere lies beneath the spacecraft. so that you can study the atmosphere, meteorological applications, hydrology, water resources, where the potential resources are there, where one has to go for a bore well or a open well, what kind of rocks are there, what kind of geological structures are there. So that kind of information. Then disaster related things also can be mapped, where the landslides are taking place, where the earthquakes, see what will be its impact on the environment. See, then soil related studies, what type of soils are there, where you have the black bottom soil, where you have the alluvial soil, where you have the lateritic soil. See, all this information you can gather by interpreting the satellite data. Then biology related, then see natural resources conservation purposes, biodiversity related studies, vegetation, then forestry related, where you have the evergreen forest, where you have the deciduous forest, mixed vegetation. See, different types of forestry can be studied. Then environmental related, if there is an impact on the environment, some mega industries are coming up, what will be its impact on the environment? See, that sort of studies, because you are getting multi-dated data. Then agricultural engineering, yes, land use development. So you can make use of this for decision-making purposes, assessment purposes, water management, how much water resources are there, surface water, groundwater and all, physical planning, so socio-economic related things, scenario studies and all, physical planning, then land surveying, topography. So for number of applications, you can make use of this satellite data, remotely sensed data products. Next slide. So next, this I have already discussed. See, now coming to GPS, global positioning system. See, now most of your mobiles are having this GPS units, the coordinates. They're monitoring the vehicle. So you can monitor through your GPS where you are, at what altitude you are, at what are the coordinates of your area, the latitude, the longitude, and the elevation information that you are getting through global positioning system. For that purpose, number of countries have launched satellites. They are having an altitude of 20 and odd thousand kilometers, nearly 22,000 kilometers. Now Star series, earlier we used to get the data from America, but now Indian Space Research Organization has launched a series of satellites for this purpose under Indian Regional Navigational Satellite System called IRNSS. Through that, we are getting the positions, the geographical coordinates, latitude, longitude, as well as the height information, and even the vehicles can be monitored with the help of navigational purposes. We are making use of this GPS, global positioning system, which comprises of space segment, control segment, and user segment. Next slide. Time aida. Next. See, for that purpose, we have number of satellites for this GPS. We have the space segment, just now I said user segment and control segment. Next slide. There are a few more slides. That is how GPS works and all. You have the control segment, you have the user segment. So people are making use of this mobile or something devices to collect the signals from the satellites. See, then you have the control segment. See, monitor stations, ground antenna, master station, and these are the satellites having an altitude of 22,000 kilometers. So next slide. See, next slide, please. These components of GIS. Next slide. See, now when we have remotely sensed data products, see, we are integrating number of thematic layers. See, then we can gather the required information for a particular geographical area. That is what it is called as geographical information system. If somebody wants to get the water resources information, forest resources information for a particular area, they can combine, they can integrate different thematic layers, and they can generate a very useful geographical information system pertaining to a particular geographical area. That is by combining remote sensing, GPS, and other technologies, computer applications, you can generate a detailed database geographical information system, which comprises of hardware, software, computers. Then you have the software, then data, remotely sensed data, field-based data, then people, that is human, where then different kinds of methodologies are there. Finally, all the data will be integrated and the required information can be gathered for a particular geographical area. That is what it is called, geographical information system. Of course, here you can see a satellite imagery, Mallur area, the color composites, even you can see the vegetation. It may be a coconut vegetation, the barren land, water bodies, shallow water. See, so much of information you will be able to gather through the analysis of remotely sensed data. If you want to carry out the detailed field work, it may be a time-consuming job. Times you may have to spend months together to collect the required information of this area. But without visiting the area, you will be able to gather the required information through the analysis of satellite data. This is our Karnataka area. Next slide, please. Hello. See, these are the Western Ghats. See, I said, see the water bodies. You have different reservoirs. It may be Harangi Reservoir, it may be Tungar, Bhadra Reservoir, Netravati River, Gurupur River, Mulki Pavanje River, Udyavara, Sita Surna, Chakra Kollur Haladi. See, from Mangalore up to Kundapur, the coastal area has been covered. In addition to that, you have the Western Ghats, you have the water bodies, the river system, from the origin of the river to the river mouth. See, you can see what type of topography is there, what type of geological features are existing. See, so much of this is, of course, the near infrared band, and there the water absorbs all the electromagnetic radiation. That is why it looks black. You can see the water bodies and all, so that I can demarcate the aerial extent of the water body. The length of this river I can measure. Of course, next slide. Of course, this is the color composite, false color composite of the satellite imagery, where the vegetation is represented by red color. This is, of course, the Mulki Pavanje area, and you can skip this image. Next image. This is the coastal area, but you are getting so much of information. See, this is again the forest area, Western Ghat area, and this slide. Next slide. See, water bodies and all. Then some of the geological features, go back to the previous slide. See, you can see some of the linear features that are called lineaments and all. See, abrupt ending of the Ghats and all. I can make use of this process data for number of applications. I will be able to get some meaningful information by analyzing these satellite images. So next slide. So these are some more images. The processed output, you require a special software package for the analysis of this satellite data. Next slide. Of course, this is Talakaveri area, and most of you are aware, last year there was a severe landslide, and this area moved, and the entire house, see, whatever the houses located here, they got completely destroyed because of this landslide. And this is the Talakaveri, that entrance, and this hillock moved, and it moved quite far off, maybe a kilometer it moved, and so much of slurry and soil, so moved from this place to this place. So severe landslides, that was because of the intensive rainfall and because of the lithology of the area. It is highly fractured rocks, highly weathered rocks are there. So number of reasons are there. But anyhow, we can make use of the satellite data. Of course, this is the satellite data. So like that, you can detect the forest fire. See, next slide, please. Next slide. Hello. Can you move the slide? Hello. See, again, you can see, and this is, see, the forest fire and all. This can be detected again through thermal sensors. They records the thermally emitted radiation. See, the damage and all you can assess with the help of this type of satellite data. Next slide. See, this is again that Mannangeri, Madikeri area where the severe landslides occurred. You can see the siltation in this area, sedimentation in this area. See, the soil got moved from one place to another because of the steep slope and all. They got deposited here. That you can see. There are a number of images showing these things. Next slide. Next. See, these are the applications wherein we can also go back to the previous slide. Just a minute. Hello. See, wildfires, uses of remote sensing for disaster management, for wildfires, avalanche, earthquake, flooding, drought, refugees, volcanic eruptions, tsunamis, landslides, extreme weather, diseases, for military operations. For number of applications we can make use of. This is pertaining to disasters. We can make use of the satellite data for geological mapping, geomorphological mapping, land use, land cover, soil delineation, forest resources mapping, agricultural resources mapping and all. Next slide. See, this is a place where the landslide occurred long back during 2005, but these type of features can be monitored. So reactivation along an older landslide surface, 30,000, 5,000 years, 6,000 years ago and 1995, potential solution, relocate people and better land use regulation. See, once we have the multi-dated satellite data, we can monitor the significant changes. What was the condition prior to the landslide, after the landslide and all, then we can take precautionary measures. I will not discuss. This is some of the basic things related to landslide. Next slide. See, these are the slopes which are responsible for the landslides and all. Wherever you have the steep slope, that is also one of the reason. So we are cutting the vegetated area. We are making road network and all by cutting the Western Ghats and all. So because of that, sometimes we have the natural, sometimes we have the anthropogenic. So these are the factors responsible for landslide, natural as well as anthropogenic. So next slide. See, here you can see some of the activities are going on in and around the Western Ghats, that you can see very clearly by analyzing the satellite images. See, they are clear. They have cleared the forest area. They are making the roads. So wherever the degradation of the environment is taking place, that can be monitored with the better accuracy with the help of satellite data. Next slide. Next slide. See, these are the slopes. You can skip these slides. Yes, you can skip these slides. Some of these slides, types of landslides. And you can see some more images where the deposition, you can see during the time of landslide, from the hilltop, the sediment, this soil got moved and it got settled here. So prior to the landslide, what was the condition? After the landslide, what has happened? So all these, see, these are the multi-dated images. So you can skip these slides. Some of these slides you can skip. Next. See, these are the areas where the sediment got deposited. So come up to this. See, these are some of the field photos. See, here also you can see so much of land moved to this place. And some of the rivers became very wider. Earlier it was very narrow rivers. Now see, they got widened. And you can see the deposition along the river course and all. See, such kind of studies can be carried out by using more than one dated satellite data. Just now I said, see, the same satellite can pass over an area number of times. That is in case of a single satellite. But we have constellation of satellites, group of satellites. So definitely with this type of satellites, every day, whatever the things happening, that we can monitor. That is possible with the help of multi-dated satellite data, multispectral, that is recording the signals at a different wavelength of the spectrum. Multi-dated is monitoring the changes at regular intervals, different time periods, time series data we are getting, so that we can monitor the changes. See, this is of course some of the field photos. In fact, I visited some of these places. This is near Madikeri area. Just can you move the slide? Hello. See, this is where the landslide occurred about 2 years back during 18 and 19, 3 years back and 2 years back along Mangalore-Mysore highway. See, these are the Western Ghat area, thickly covered with forest. But see, the entire road got disturbed because of this landslide and all. So these are some of the photographs. See, the land completely moved. One reason for the landslide was this area is highly fractured, having highly fractured rocks. The soil cover is very thick. Then intensive rainfall. The intensity of rainfall was very high. Just in 3 days, this area received about 600 millimeters of rainfall. That was also one of the reasons. So that is why landslides occurred in these places. You can see one more imagery. See, there is a hanging, see, small hut. See, you can see the slope of this land. Because of this landslide, these things have happened. there is a change in the land cover. So that can be monitored. Just now I said, see, before the landslide, what was the condition? After the landslide, see, images are available. You make use of the images, generate the maps, and provide the solution to the district authorities. How best this technology can be used for mapping purposes, for monitoring purposes. This is, of course, some of the photograph. Of course, when I say the photograph, which is also a part of remote sensing, see, so much of wooden, see, blocks came from the hilltop. See, you can see those pictures here. Everywhere you can see the landslide and its impact. It damaged a house near Monnangeri area on the way to Madikeri from Mangalore. So, okay, you can skip some of the slides are repeated. Okay, you can see. Yes. See, one more here, one more slide is there. Just see, if you want to have more information, see, my website is available. That is www.hejamadi Gangadhar. You can make use of this website and you can download some of the information, required information related to remote sensing and all. Then my YouTube channel is also there. That is Hejamadi Gangadhar. But if you visit that channel, you are getting some videos so that you can download some of the videos related to remote sensing, water resources and all. In fact, water resources is also one of the important topics. See, after getting so much of rainfall, maybe in your area also, you are experiencing, even in fact, northern Karnataka, see, during monsoon season, especially that Gadag, Belgavi area, northern Karnataka, Bijapura, part of Bijapura and all, Rayachur experiencing severe rainfall. And some of the districts during non-monsoon season experiencing severe droughts. So maybe the same area or some other areas are experiencing floods and droughts. Now, how best this can be monitored, even after getting so much of rainfall, why we are facing acute shortage of rainfall? Of course, in Dakshina Kannada or Dakshina Kannada and Udupi district, we are getting more than 3,500 to 4,000 millimeter of rainfall. With all that, we are facing acute shortage of water during peak summer. So there is a need for water conservation. We talk about conservation, watershed management, watershed characterization, watershed prioritization and all. And for this purpose, remote sensing is one of the best tool, and whatever the water falls on the roof can be collected and that can be used for recharging purposes. You can recharge the aquifers, you can recharge your well, you can recharge your bore well with the available water. See, that is coming under water harvesting, watershed management and all. So if you want to have more details, you can visit this YouTube channel and you are getting some information. Next, no, just go back to the one minute. So, see, then even I used to write some popular articles in Kannada. They are available if you visit Facebook. So Hejamadi Gangadhar, but there some popular science articles are available on remote sensing, then water harvesting, then some of the current issues and all. Then my email ID is also there. My contact number is there. If anybody wants to have more information, you can contact me. And again, if there are any specific questions, I will be able to answer your questions. Is there any specific questions? With this, I will conclude my lecture. The last slide. Thank you all for your patient hearing. Thank you one and all. And I must thank Professor Madhukumara and Karabasappa H. Badagi for giving me an opportunity to share some of my thoughts. So thank you once again.
Thank you, sir. The session is open for
hearing my
discussion.
lecture. It is open for discussion. If there are any specific questions, I will be able to answer your questions.
Yes, yes.
And again, I am thanking for all of you for your patient hearing, and especially my special thanks to Dr. Madhu Kumar and Professor Karabasappa H. Badagi. Thank you. If there are any specific questions, sir, I will be able to answer.
Sir, I have a small question, sir.
Okay, tell me, sir.
Yes, sir. Yes, sir. Which deep ocean process and structure can be determined by satellite remote sensing and modeling?
Which spectral bands?
Yes, sir. Yes, sir.
Sir, can you repeat that, sir? Because audio was...
Which deep ocean process and structure can be determined by satellite remote sensing and modeling?
Ocean related studies you are talking about, ocean depth
Yes,
and
yes,
all.
yes, sir, yes, sir.
Yeah, for that, yes, we have to go for microwave remote sensing. Since you are basically a physics man, definitely you may be knowing the basic principles of remote sensing physics. See, microwave remote sensing, longer wavelengths that can penetrate. We have satellite oceanography. So we have imaging sensors and we have non-imaging sensors, especially the optical sensors, which functions in the visible region of the electromagnetic spectrum. They are used for near shore processes. When we talk about the open ocean, we have open ocean water and near shore waters. Case 1 and case 2 water. Open ocean waters are deep waters, and if somebody wants to study the bottom topography and all, for that again we have to make use of sonar technology, sound navigation and ranging by sending the sound pulses. Then you have to determine the bathymetry and all. And at the same time, the microwave remote sensing technology, we have interferometric techniques are available. We have radar technologies are available, radio detection and ranging. They can penetrate up to few meters. And by studying the roughness of the ocean surfaces, you can indirectly determine the bottom topography and all. So number of applications are there when we talk about remote sensing. The technology is advancing because 71% of the Earth's surface is covered with the oceans. By ships or by boats, we cannot collect the real-time or near real-time data. Definitely by using different portions of the electromagnetic spectrum, which functions in the visible, infrared, thermal infrared, microwave portion of the spectrum, we will be able to get the required information of the oceanic surfaces in a better way. No other conventional techniques provides the required information other than satellite images.
Thank you, sir.
Okay, thank you.
So any questions for participant?
If there are geology related or any natural resources related researchers, they can ask few questions like Dr. Madhu Kumar. He asked a few questions, and in fact, he did his PhD here only in our university. I am feeling proud about him, and again I am thanking him for calling me and inviting me to deliver a lecture on
Thank
this
you.
topic. I think the topic is clear now. If you have any doubts, they can ask questions. They can contact me over the phone. They can contact me through email and all.
Hello, sir.
Tell me, sir.
Sir, about the water saving harvesting, sir.
Okay.
One can do in the terrace itself. We can make an arrangement and then we can collect, sir.
Yes, definitely. See, you can go to my WhatsApp. If you give your number, if you make a call to me, I will send you some materials, reading materials. See, if there is a rainfall of 1 inch in a rooftop area of 1,000 square feet, you can gather about 600 and odd gallons of water, nearly 2,000 and odd liters of water. See, that water can be collected. Maybe in the beginning, you may not be able to collect the water, or you need not collect the water. But after 1 or 2 rainfall, the later rainfall, whatever the water collected after that you can collect and you can store it in a sump. But for that, you require a filter unit comprising of pebbles, sand, and all. Filter unit must be there. The collected water must pass through that filter unit, and later you have to collect that water, fresh water, that filtered water in your sump or tank. That is possible because there is a need to conserve the water. Everywhere we are facing the acute shortage of water. Your question is very much relevant. You can do that. You can practice it by making use of the rooftop. You collect the water, clean it, and pass it to the filter unit. Then that water you can transfer it to your sump or tank. That water even you can make use of for drinking purposes. If you want to have more details, you can
sir.
contact
Thank you. Thank you very much, sir.
Thank you.
Hello.
Thank you.
Okay, sir. Thank you.
Hello.
Thank you for the explanation, sir.
Okay, thank you. Thank you, sir.
Hello, good evening, sir.
Is it clear?
Hello, good evening.
Good evening.
Yes,
Tell
sir.
me,
It is clear, sir.
Tell me, sir.
Sir, one more question.
Okay, tell me, sir.
I am from a drought area.
Okay, okay. Which place, sir?
So that is Kudligi,
Okay,
Bellary
okay.
district.
Kudlagi.
So, is it possible to identify the resource of water in the drought area with the help of a sensor?
Yes, definitely, sir. But mostly in your
Yeah.
drought area, see, whatever the water available, that was 10,000 years old water, maybe paleo water, ancient water. Now your area is not getting sufficient rainfall, is it not?
Yeah,
Sir, what
yes, sir.
happens normally, people will go for wells, bore wells and all. Now, even at a depth of 1,500 meter,
Yeah.
you are not getting water. Maybe the same thing you are experiencing also. Being
Yes,
a
sir.
farmer, if you go for a bore well, even at
Yeah.
a depth of 1,500 feet, you are not getting water because
Yes, sir.
we have overexploited the water. But
Yeah.
definitely, if there is a rainfall, you can store the water. You can make some small tanks. Whenever the rain falls on your open space also, that
Yeah.
water can be stored, and in your farm, whatever the rainfall comes, maybe you are getting some 400 to 500 millimeter of annual rainfall, it seems. Am I right, sir? Are you getting
Yeah,
that
correct,
much?
sir.
Yeah, that water, whatever the water comes during monsoon season, the rainfall, that you can store in your farm, and you can make ditches or ponds or a small tank open,
Yes.
as well as sump you can make. That water you store, and if you have a well or a bore well, you can divert that water to the well or bore well through a filter unit. That is possible. I will send some more details if you want to implement any scheme there in your residence or very close to your residence. I will give you some action plans and you can contact me. See, the thing is, whenever there is a rainfall, that water can be stored. We have to store that water because
Yes.
water is an important natural resources. We are simply allowing it to flow. We must catch the water whenever it falls on the rooftop or on the open area. Then
Yeah.
make use of that water for recharging. Definitely, the water table will come up, especially during monsoon season. Even you can recharge your well or bore well. Even the bore wells can be recharged, sir. Nowadays
ಓಪನ್
it is
ಇರಲ್ಲ, ಒಳಗೆ
possible.
ಕೇಳಿದ್ರೆ ಹೇಳ್ತಾರ, ಈ ಪಕ್ಕ ಗೇಟ್ ಐತಲ್ಲ ಅಲ್ಲಿ.
Open well or bore wells can be
ಹೇಳ್ಬಿಟ್ಟು
recharged.
ಹೇಳಕ್ ಬರಲ್ಲ.
Okay.
ಡೆಫಿನೆಟ್ಲಿ ದಟ್ ಕ್ಯಾನ್ ಬಿ ರೀಚಾರ್ಜ್. ನಿಮ್ಮ ವೆಲ್ಸ್ ಅಥವಾ ಬೋರ್ ವೆಲ್ಸ್ ಅನ್ನು ಖಂಡಿತವಾಗಿಯೂ ನೀವು ರೀಚಾರ್ಜ್ ಮಾಡಬಹುದು. ಎಷ್ಟು ಮಳೆ ಬರ್ತದೆ ಆ ಬೇಸಿಸ್ ಮೇಲೆ ನೀವು ನಿಮ್ಮ ಸುತ್ತಮುತ್ತ ಇದ್ದ ನೀರನ್ನೆಲ್ಲ ಕಲೆಕ್ಟ್ ಮಾಡಿ ನೀವು ಅದನ್ನು ಸಂಪ್ ಅಥವಾ ಒಂದು ಸಣ್ಣ ಟ್ಯಾಂಕ್ ಮಾಡಿ ಅದಕ್ಕೆ ಡೈವರ್ಟ್ ಮಾಡಿ ಅದರಿಂದ ಫಿಲ್ಟರ್ ಮಾಡಿ ನೀವು ನೀರನ್ನು ಕಲೆಕ್ಟ್ ಮಾಡಿದ್ದೆ ಆದರೆ ಖಂಡಿತವಾಗಿಯೂ ನೀವು ನಿಮ್ಮ ಸುತ್ತಮುತ್ತ ಎಲ್ಲ ನೀರನ್ನು ಸಂಗ್ರಹಿಸಬೇಕು. ಖಂಡಿತವಾಗಿ ನಿಮ್ಮ ಬೋರ್ವೆಲ್ ಅನ್ನು ಯು ಕ್ಯಾನ್ ರೀಚಾರ್ಜ್ ಯುವರ್ ಬೋರ್ವೆಲ್ ಆಸ್ ವೆಲ್ ಆಸ್ ಯುವರ್ ಓಪನ್ ವೆಲ್ and you can improve the water table. That is possible. Drought area dallu possibility ide ಖಂಡಿತವಾಗಿಯೂ. There are number of successful stories available even for the drought area, sir. Definitely it is possible. But ನಿಮ್ಮ ಕ್ವಶನ್ ತುಂಬಾ ರೆಲೆವೆಂಟ್. ಇಂತ ಖಂಡಿತ ನಿಮ್ಮಂತವರಿದ್ರೆ ಹಳ್ಳಿಯಲ್ಲಿ ಇನ್ನೂ ಜಾಸ್ತಿ ನೀವು ರೀಚಾರ್ಜ್ ಮಾಡೋದ್ರಲ್ಲಿ ನಿಮಗೂ ಮಾತ್ರ ಅಲ್ಲ ನಿಮ್ಮ ಸುತ್ತಮುತ್ತಲಿನವರನ್ನು ನೀವು ಇದು ಮಾಡಬಹುದು. ಖಂಡಿತವಾಗಿಯೂ ನೀವು ಆದರ್ಶ ರೈತ ಆಗಿ ನೀವು ಸುತ್ತಮುತ್ತಲಿನ ಏರಿಯನ್ನು ರೀಚಾರ್ಜ್ ಮಾಡಿದ್ರೆ ಡೆಫಿನೆಟ್ಲಿ we can conserve our resources. It is possible, sir. Definitely there are solutions. Drought monitoring areas, even those areas can be recharged.
Yes, yes. Okay, sir. Thank you very much. Thank you very much.
Okay, sir. Okay, sir. Is it okay?
Okay, sir. Correct.
Okay, then you can contact me, sir. I have some WhatsApp articles. I will send it to you if you have that
Okay, sir.
WhatsApp number.
ಸರ್ ಶೇರ್ ಮಾಡಿದ್ರಿ ಎಲ್ಲ ಸರ್ ಶೇರ್ ಮಾಡಿ.
ಆಗ್ಲಿ ಸರ್, ಒಳ್ಳೇದಾಗ್ಲಿ, ಎಲ್ರಿಗೂ ಒಳ್ಳೇದಾಗ್ಲಿ. ಬಹಳ ರೆಲೆವೆಂಟ್ ಕ್ವಶನ್ಸ್ ಎಲ್ಲ. ಇದು ತುಂಬಾ ಟೆಕ್ನಾಲಜಿ ಬಹಳ ಯೂಸ್ಫುಲ್. ರಿಮೋಟ್ ಸೆನ್ಸಿಂಗ್ ನಿಮ್ಮ ಗದಗ್ನಲ್ಲಿ ಕರ್ನಾಟಕ ಸ್ಟೇಟ್ ಇದು ಡಿಸಾಸ್ಟರ್ ಇದೊಂದು ಇದೆ. ನಿಮ್ಮ ಗದಗ್ನಲ್ಲಿ ಒಂದು ಯೂನಿವರ್ಸಿಟಿ ಇದೆ ಸರ್, ಕರ್ನಾಟಕ ಸ್ಟೇಟ್ ರೂರಲ್ ಡೆವಲಪ್ಮೆಂಟ್ ಅಂಡ್ ಪಂಚಾಯತ್ ರಾಜ್ ಯೂನಿವರ್ಸಿಟಿ ಅಂತ ಹೇಳಿ. ಅಲ್ಲಿ ಸಾಕಷ್ಟು ಕೆಲಸ ಮಾಡ್ತಾ ಇದ್ದಾರೆ ಅವರು. ಈ ಇದನ್ನೆಲ್ಲ ಹಳ್ಳಿಗಳಿಗೆಲ್ಲ ತಲುಪಿಸ್ಲಿಕ್ಕೆ ಸ್ಯಾಟಲೈಟ್ ಟೆಕ್ನಾಲಜಿ. ನಮ್ಮಲ್ಲಿ ಜಿಯೋ ಇನ್ಫಾರ್ಮೆಟಿಕ್ಸ್ ಅಂತ ಇದೆ. ಬನ್ನಿ ನಮ್ಮಲ್ಲಿ ಒಮ್ಮೆ. ನಿಮ್ಮ ಡಾಕ್ಟರ್ ಮಧುಕುಮಾರ್ ಕೋಆರ್ಡಿನೇಟರ್ ನಮ್ಮ ಯೂನಿವರ್ಸಿಟಿಯಲ್ಲಿ MSc PhD ಮಾಡಿದವರು. ಅವ್ರ ಜೊತೆ ಬನ್ನಿ ನಮ್ಮ ಯೂನಿವರ್ಸಿಟಿಗೆ ಸಹ. ನಿಮಗೂ ಸಾಕಷ್ಟು ವಾಟರ್ ಹಾರ್ವೆಸ್ಟಿಂಗ್ ಬಗ್ಗೆ ಮಾಹಿತಿ ಕೊಡ್ತೇವೆ ಸರ್. ಖಂಡಿತವಾಗಿಯೂ ನಮ್ಮಲ್ಲೂ ಜಿಯೋ ಇನ್ಫಾರ್ಮೆಟಿಕ್ಸ್ ಕೋರ್ಸ್ ಇದೆ, ಮೆರೈನ್ ಜಿಯಾಲಜಿ ಇದೆ, ಸಮುದ್ರ ಇದೆ. ಸಮುದ್ರ ನೋಡ್ಲಿಕ್ಕಾದ್ರೂ ಬನ್ನಿ ಸರ್. ನೀವು ನೋಡಿರ್ಬಹುದು. ಬಟ್ ಐ ಆಮ್ ಇನ್ವೈಟಿಂಗ್ ಒನ್ಸ್ ಅಗೇನ್ all of you to come to Mangalore. Thank you, sir.
Okay, sir. Thank you, sir. Thank you.
Okay. Thanks, sir.
Thank you so much, sir.
Thanks. I must thank all of you for giving me an opportunity and for listening me. Thank you once again for all of you. especially to Dr. Madhu Kumar. Thank you.
Thank you.
And to Dr. Karabasappa, Professor Karabasappa sir.
Thank you, sir. Thank you, sir. Thank you.
Thank you. Thank you. Okay. Okay.
Sir, vote of thanks. Good evening to all. On behalf of KLE, GH College Haveri and RTS College Ranebellore, I take this opportunity to propose a vote of thanks to those who have directly and indirectly contributed to this 7 days national FDP on recent trends in research organized by Science Association of GH College Haveri and RTS College Ranebellore. At the outset, I thank our chief guest and resource person, Dr. Gangadhar Bhatt, Professor, Department of Marine Geology, University of Mangalore, for making excellent presentation and making this FDP interesting and meaningful, and we are really enlightened with your knowledge and presence. We are thankful to our honorable chairman, Dr. Prabhakar Kole, KLE Society Belagavi, and Honorable President Sri Subhash Saukar, RTS Society Ranebellore, and MC Kolle Board of Members KLE Society Belagavi for their support. I express my heartfelt thanks to our beloved principals, KLE GH College Haveri and RTS College Ranebellore, for encouragement and guidance for encouraging 7 days FDP program. I thanks to all other distinguished delegates, faculty and students from our and other institutions. I special thanks to the IQAC and organizing committees, teaching and non-teaching staffs of their support and coordination, and made the program more meaningful. Once again, I thank you all for your attention. Thank you, one and all.
Thank you, sir.
Thank you, sir.
Gangadhar Bhatt